So good morning, welcome back to Sakala Vidya Education Channel. So welcome to our engineering mathematics classes. So in the last session we have discussed 6 problems on D'Alembert's ratio test in the part of infinite series. So today we are going to do some more interesting problems on D'Alembert's ratio test. So without wasting our time, so directly switch over to our problems. So now let us move to the first problem. That means today's first problem, that is 7th problem. Already we have completed 6 problems. This is 7th problem. 7th problem. Discuss the convergence of the following series of the series, or sometimes following series also may be given. Following series. So 1 plus 2 to the power of p by 2 factorial plus 3 to the power of p divided by 3 factorial plus so on p greater than 0. So we need to test the convergence of the given series, convergence or divergence of the given series. So first of all, if you observe the series is actually involves the factorial terms. So whenever series involves the factorial terms, so we need to apply D'Alembert's ratio test. So now here actually nth term is not given. First we need to decide the nth term. After that we can proceed for even applying the D'Alembert's test, D'Alembert's ratio test. Okay, let us go for the solution now. Solution. So here nth term un is equal to, here 1 to the power of p 1 only, by 1 factorial we can write. So this is 2 to the power of p by 2 factorial, 3 to the power of p by 3 factorial. So un obviously becomes what now? 1 comma 2 comma 3, nth term is n, so n to the power of p you can write. So next we have 1 factorial, 2 factorial, 3 factorial, so on we have n factorial. Obviously this will be the nth term. So now what we need to find out? So now let us find out un plus 1. So un plus 1 equals to n plus 1 whole to the power of p. That means in the place of n write down n plus 1. So n factorial, in the place of n write down n plus 1, that is n plus 1 factorial. So first, before going to apply the D'Alembert's ratio test, let us actually evaluate un by un plus 1. So consider un divided by un plus 1. So that means un means n to the power of p by n factorial divided by n plus 1 whole to the power of p divided by n plus 1 factorial. So let us make it simplify. So how to simplify? See, this can be simplified. N to the power of p by n factorial multiplied with reciprocal of the denominator, that we can write n plus 1 factorial divided by n plus 1 factorial, sorry, n plus 1 whole to the power of p. So very beautiful property we have in factorial. N plus 1 factorial can be written as n plus 1 into n factorial. So that means n to the power of p by n factorial into n plus 1 factorial means n plus 1 into n factorial by n plus 1 whole to the power of p. Clear? So now what do we write? N factorial got cancelled. We have n to the power of p into n plus 1. that is n to the power of p into n plus 1 by n plus 1 whole to the power of p. So, in the denominator we have n plus 1, in the numerator is n plus 1 whole to the power of p. Using a to the power of m by a to the power of n, you can write a to the power of m minus n form. So, n plus 1 by n plus 1 whole to the power of p, we can write n to the power of p by this n plus 1 whole to the power of p minus 1, that we can write it. Clear, I hope. So, again what shall we do now here? From n plus 1 in the denominator n plus 1 whole to the power of p minus 1, take n common out, indirectly n to the power of p minus 1 take n common out. So, n to the power of p divided by here n to the power of p minus 1 common, we get 1 plus 1 by n whole to the power of p minus 1. Again n to the power of p by n to the power of p minus 1 is a to the power of m by a to the power of n, a to the power of m minus n, p minus of p minus 1, p minus p plus 1, p gets cancelled, it becomes n itself only. So, that means we are going to write this is equal to, you can write like this. So, now write this is equal to n to the power of p by n to the power of p minus 1 is n upon 1 plus 1 by n whole to the power of p minus 1. It is the simplified form of un by un plus 1. That means un by un plus 1 as simplified as n divided by 1 plus 1 by n whole to the power of p minus 1. Now, you can apply D'Alembert ratio test. So, now we are going to apply D'Alembert ratio test. See, now we need to apply. So, by D'Alembert's ratio test. So, limit n tends to infinity un upon un plus 1, limit n tends to infinity, So, what is un by un plus 1? N divided by 1 plus 1 by n whole to the power of p minus 1. So, n divided by 1 plus n whole to the power of this is 1 minute, let me write. This is n divided by 1 plus 1 by n whole to the power of p minus 1. See, as n tends to infinity, here see, as n approaches to infinity, so as n tends to infinity, n approaches to infinity, so 1 by n tends to 0. That means 1 by n becomes 0, but n is infinity itself only. So, we can have here, this is infinity divided by 1 plus 0 whole to the power of p minus 1. So, that is equal to infinity by 1 plus 0, 1 to the power of something is 1, that is infinity itself only. Infinity is a positive infinity, so always greater than 0. So, as for the D'Alembert's ratio test, see, limit n tends to infinity un by un plus 1 is a greater than 0, it is convergent, less than 0 divergent, is equal to 0 test fails. So, that means actually you remember only one thing, by D'Alembert's ratio test, limit n tends to infinity un by un plus 1 is equal to L, which is greater than 0, or we can say that then it is actually, what do we say? So, n is we can write like this, better you can write, it is greater than 1. Greater than 1 means convergent, less than 1 means divergent, is equal to 1 fails. So, that means greater than 1. So, therefore, we can state that hence sigma un, our given series is convergent. convergent. I hope it's very clear. Please all of you note down. Let us go to the question once again. Let us go to the question once again. See, the question will be given like this in the examination. Discuss the convergence of the series 1 plus 2 to the power of p by 2 factorial plus 3 to the power of p by 3 factorial plus so on, where p greater than 0. P is positive itself only. So, here nth term we need to write 1 comma 2 comma 3 arithmetic progression. So, obviously nth term is n, but power is raised to p, n to the power of p divided by. So, here we have 1 factorial, 2 factorial, 3 factorial, 1, 2, 3 are in arithmetic progression, n factorial you will be getting. So, nth term of the given series is un is equal to n to the power of p by n factorial, as it is consisting of n factorial. Now, it is not geometric series, it is not actually 1 by n to the power of p. So, that is why we need to go for the, it is not in the form of f of n by g of n, as it is consisting of n factorial. When it involves n factorial terms, now we need to apply the D'Alembert's ratio test. You remember that one, how to identify the test means. So, now we need to find out un plus 1 in the place of n, n plus 1 whole to the power of n plus 1 write down, that is n plus 1 whole to the power of p. In the place of n, n plus 1, but factorial we need to write factorial. Now, you need to consider un by un plus 1, n to the power of p by n factorial divided by n plus 1 whole to the power of p by n plus 1 factorial. So, this equals to what you write now, n to the power of p by n factorial multiplied with reciprocal of this one, that is n plus 1 factorial by n plus 1 whole to the power of p. This n to the power of p by n factorial into n plus 1 factorial is a shifting property. We can write n plus 1 into n factorial by n plus 1 whole to the power of p. N factorial got cancelled. We have n to the power of p into n plus 1 by n plus 1 whole to the power of p. N plus 1 by n plus 1 whole to the power of p is using exponents and powers, a to the power of m by a to the power of n, a to the power of m minus n. So, n to the power of p by n plus 1 whole to the power of p minus 1. From n plus 1 whole to the power of p minus 1, first of all take n common from n plus 1. So, power is p minus 1. So, obviously we get n to the power of p minus 1 common out. N to the power of p by n to the power of p minus 1 into 1 plus 1 by n whole to the power of p minus 1. So, now my dear students, you see this n to the power of p by n to the power of p minus 1 is a to the power of m by a to the power of n, a to the power of m minus n. So, p minus p plus 1, that is n to the power of 1 n only, n by 1 plus 1 by n whole to the power of p minus 1. So, next now by D'Alembert's ratio test, by applying limit n tends to infinity un by un plus 1, limit n tends to infinity n by 1 plus 1 by n whole to the power of p minus 1. As n approaches to infinity, 1 by n tends to 0. So, that is why in the place of 1 by n 0, in the place of n infinity. Infinity by 1 plus 0 whole to the power of p minus 1, 1 to the power of p minus 1 is 1, p is positive, p minus 1 is also obviously positive. So, we get an infinity by 1 is positive infinity, that is greater than 1. So, sigma un is convergent. If it was less than 1, then we say that it is divergent, but absolutely it is convergent itself only, right. This is the question number 7. So, let us move to the question number 8. Question number 8. Question number 8. Note down the question number 8. This also discuss the convergence of the series itself only. So, 1 upon 2 plus 1 upon 3 plus 1 upon 5 plus so on plus 1 upon 2 to the power of n minus 1 plus 1 plus so on. So, we need to test, as it is consisting of actually here when un involves here involves only one power term means 2 to the power of something, 3 to the power of something, 4 to the power of something, are same base terms, then we can apply D'Alembert ratio test. This is the actually we need to identify the test itself only. So, in order to solve this question, first of all, already nth term is given, pick up the nth term, write down the nth term. After that, find un plus 1. So, next after that, by first of all simplify un by un plus 1. By D'Alembert test, apply the limit n tends to infinity, check whether greater than 1 or less than 1. Accordingly, you need to write whether it is a convergent or divergent. So, this sort of strategy need to be applied to solve this problem. Okay, let us start. Here solution. So, here nth term given un equals to 1 divided by 2 to the power of n minus 1 plus 1. Now find un plus 1. So, 1 divided by 2 to the power of, in the place of n write down n plus 1, but minus 1 is there and plus 1. Plus 1 minus 1 cancel. This is 1 divided by 2 to the power of n plus 1. Right? Am I right now? So, next what do you get now here? So, therefore, find un by un plus 1. So, un means 1 upon 2 to the power of n minus 1 plus 1 divided by un plus 1, 1 divided by 2 to the power of n plus 1. So, this equals to, what do you write now here? This equal to, you can write 1 divided by 2 to the power of n minus 1 plus 1 multiplied with reciprocal of 1 by 2 to the power of n plus 1, that is 2 to the power of n plus 1 upon 1. And this we can write it as, it can be written, so 2 to the power of n plus 1 into 1, 2 to the power of n plus 1, 2 to the power of n minus 1 plus 1 into 1, 2 to the power of n minus 1 plus 1. So, in the denominator, let us take out 2 to the power of n minus 1 common. In the numerator, take out 2 to the power of n common. 2 to the power of n common, we have 1 plus 1 by 2 to the power of n divided by, here 2 to the power of n minus 1 common. So, we get 1 plus 1 by 2 to the power of n minus 1. Right, clear? So, then what do we get now here? So, 2 to the power of n by 2 to the power of n minus 1, that is in the form of actually a to the power of m by a to the power of n. So, we can apply a to the power of m minus n formula. A to the power of n by a to the power of n, a to the power of m minus n. So, what do we write? This equals to 2 to the power of n minus of n minus 1, n minus n plus 1. So, 1, 2 times you will be getting. So, 1 plus 1 by 2 to the power of n divided by 1 plus 1 by 2 to the power of n minus 1. Now, we have simplified the value of un by un plus 1. Now, we can apply, what is the next step we need to do? We need to apply D'Alembert ratio test, that need to be applied here. So, now by D'Alembert's ratio test. So, limit n tends to infinity, un divided by un plus 1. So, that is equal to limit n tends to infinity 2 multiplied with 1 plus 1 upon 2 power n divided by, we have actually what we have, that is nothing but 1 plus 1 by 2 to the power of n minus 1. Am I right now? Go back. 2 into 1 plus 1 by 2 power n by 1 plus 1 by 2 power n minus 1. Right. Now actually 2 is the constant. Let us take 2 common. Now limit n tends to infinity, 1 plus 1 by 2 power n divided by 1 plus 1 by 2 power n minus 1. So here very interesting. See, as n tends to infinity, this 2 to the power of n also tends to infinity, and even 2 to the power of n minus 1, that is 2 to the power of n by 2. 2 to the power of n by 2 means infinity by 2, it's also infinity itself only. That means here 1 by 2 to the power of n, 1 by 2 to the power of n and 1 by 2 to the power of n minus 1 obviously tends to 0, because 1 by infinity 0, 1 by infinity 0. So this becomes 0, this becomes 0. So we can write now 2 of 1 plus 0 by 1 plus 0. 1 plus 0 by 1 plus 0, 1 by 1, 1. So 2. 2 is greater than 1. As limit tends to infinity, un by un plus 1 is greater than 1. Therefore, or hence we can write sigma un is convergent by D'Alembert ratio test. Convergent. I hope it's very clear to you. I hope it's very clear to you. Right. See, you are asked to test or discuss the convergence of the series 1 by 2 plus 1 by 3 plus 1 by 5 plus so on plus 1 by 2 to the power of n minus 1 plus 1 and plus so on. Here nth term is given, this is the nth term. Un is equal to 1 by 2 power n minus 1 plus 1, as it is consisting of actually something what it involves power term. Power term is 2 to the power of n minus 1 plus 1. So we need to apply D'Alembert ratio test, that's all. So that means now in order to apply the D'Alembert test, we need to find out un plus 1 value. In the place of n, replace n minus 1. N in the place of n, 1 by n plus 1 minus 1 plus 1. Plus 1 minus 1 got cancelled. 1 by 2 power n plus 1 we will get it. First let us simplify un by un plus 1 is equal to 1 by 2 power n minus 1 plus 1 divided by 1 by 2 power n plus 1. Right. Now actually 1 by 2 power n minus 1 plus 1 into reciprocal of this one, that is 2 power n plus 1 by 1, 2 power n plus 1 by 1. So we get 2 power n plus 1 by 2 power n minus 1 plus 1. From numerator take 2 power n common, from denominator take 2 power n minus 1 common. If you take 2 power n common, 1 plus 1 by 2 power n divided by, if you take 2 power n minus 1 common from the denominator, we get 1 plus 1 by 2 power n minus 1. Now 2 power n by 2 power n minus 1 is in the form of a power m by a power n, so that we can write a power m minus n formula. So this is 2 to the power of n minus, you will be getting like this, n minus of 2 to the power of n minus of n minus 1. That is 2 to the power of n minus n minus into minus plus 1. So 2 to the power of 1 means obviously 2 only. 2 into 1 plus 1 by 2 power n divided by 1 plus 1 by 2 power n minus 1. Now apply the limit. So next by D'Alembert ratio test, limit n tends to infinity un by un plus 1. Limit n tends to infinity 2 into 1 plus 1 by 2 power n by 1 plus 1 by 2 power n minus 1. So 2 constant take common out and apply only to the function. Limit n tends to infinity 1 plus 1 by 2 power n by 1 plus 1 by 2 power n minus 1. 1 by 2 power n, as n tends to infinity 1 by 2 power n is 0. As n tends to infinity 1 by 2 power n minus 1 is also 0. Because as n tends to infinity 2 power n tends to infinity, 2 power n minus 1 also tends to infinity. 1 by infinity is 0, 1 by 2 infinity also 0. So these both are tend to 0 itself only. So 2 times 1 plus 0 by 1 plus 0. So 1 by 1 1. So 2 is obviously greater than 1. So as limit tends to infinity, un by un plus 1 is greater than 1. Hence sigma un is convergent. So 8th problem has been completed. Let us move to 9th problem now. 9th problem. Are you ready? Test the convergence of the series, given series. We need to test it. 9th question. So 1 square into 2 square by 1 factorial plus 2 square into 3 square by 2 factorial plus 3 square into 4 square by 3 factorial plus 4 square into 5 square by 4 factorial and plus so on. Right. So we need to test the convergence of the series. How to test? What sort of tests are to be applied here? Either geometric test or p-test or comparison test or D'Alembert test or some other test we need to apply. We need to discuss. So just check, the series is consisting of the factorial terms. As it is contains the factorial terms, D'Alembert ratio test has to be applied. You must remember. But before going to apply the D'Alembert ratio test, we need to find the nth term of the series. That is very important. So in order to find out the nth term of the series here, first of all, see 1 square, 2 square, 3 square, 4 square. That means write down first of all 1 comma 2 comma 3 comma 4 are in AP. So let us find out its nth term. So nth term of the arithmetic progression is a plus n minus 1 into d. First term is 1 plus n minus 1 into whose common difference is 1. So 1 plus n minus 1, 1 minus 1 gets cancelled, we have n. Obviously 1 square, 2 square, 3 square, 4 square means that is nothing but n square only. Later we can write, don't worry. Next consider 2, 3, 4, 5. 2, 3, 4, 5 are also in arithmetic progression. This is second arithmetic progression. So whose nth term has to be determined now. So using similar formula. So Tn here a is 2 plus n minus 1 into common difference is 1 only. 2 plus n minus 1. So n plus 2 minus 1 is plus n plus 1. Right. Now again actually denominator 1 factorial, 2 factorial, 3 factorial, 4 factorial, that means n only term. So therefore now you need to write the nth term of the series. Here what does the nth term here become? Here nth term is equal to un is equal to, you can write first numerator. Numerator means actually 1 square into 2 square, 2 square into 3 square, 3 square into 4 square. Actually here what nth term of the first factors n square, nth term of the second factor n plus 1 whole square. That means n square into n plus 1 whole square. So this is the, actually we have, this is the nth term of the numerator. Denominator 1 factorial, 2 factorial, 3 factorial, 4 factorial, but 1, 2, 3, 4, its nth term is n. So 1 factorial, 2 factorial, 3 factorial, 4 factorial, nth term is n factorial. By n factorial write down. So this is the our un. So now what shall we find out now? Un plus 1. Next un plus 1 you need to find out. Right. So next you need to find out un plus 1. Right. So let us find out un plus 1. un plus 1. Therefore, un plus 1. In the place of n, let us replace n plus 1. What do we get? N plus 1 whole square, n plus 1 whole square divided by n plus 1 factorial. So, further it can be simplified. N plus 1 whole square, n plus 1, n plus 2 whole square by n plus 1 factorial. Now we need to apply the D'Alembert ratio test. Actually, what we have here, nth term is n square, n plus 1 whole square by n factorial, right. Next, by D'Alembert ratio test, D'Alembert ratio test, limit n tends to infinity un by un plus 1. So, limit n tends to infinity un. What does un stand for? That is n square n plus 1 whole square divided by n factorial by un plus 1, that is n plus 1 whole square into n plus 2 whole square divided by n plus 1 factorial. Am I right? Let us check it once again yourself. So, you might be writing your notes. You can check in your notes first of all. So, all of you look at the screen carefully. Right. So, now what do we write? Let us see. Now we need to simplify. Next, this is equal to, we can write limit n tends to infinity n square n plus 1 whole square divided by right. 1 minute, I will go to the previous back. Un plus 1. Okay, before going to apply, first let us simplify this one. Let us simplify. After that, we can apply D'Alembert ratio test. So, first let us simplify. Right. So, therefore, un by un plus 1 write down. So, un means, what is un value? Un is n square n plus 1 whole square by n factorial divided by un plus 1, n plus 1 factorial, sorry, n plus 1 square, n plus 2 square by n plus 1 factorial. Now, what do we simplify? How do you simplify? Yes. So, this can be simplified n square n plus 1 whole square by n factorial multiplied with reciprocal of this one, that is n plus 1 factorial by n plus 1 whole square into n plus 2 whole square, n plus 2 whole square. Right. Just think how to simplify this one. Just think how to simplify this one. Yes, you are correct. So, now we need to apply the shifting property, that is n square n plus 1 whole square divided by n factorial multiplied with n plus 1 factorial, means n plus 1 into n factorial, right, n plus 1 factorial into n plus 2 factorial. N plus 1 factorial got cancelled, n factorial and n factorial got cancelled. we have n square. What is the value we have now here? Simplification, right? N square n plus 1 by, we have actually n factorial gets cancelled, right? N plus 1, n factor cancel, we have n square, right? Wait, what do you get now? Right, this is, you are going to get like this, n square into n plus 1 by n plus 2 whole square, right? It's correct only, right? So now let us, by D'Alembert ratio test, we need to apply. So by D'Alembert's ratio test. So limit n tends to infinity, un divided by un plus 1, that is limit n tends to infinity, right? Now here n square n plus 1 divided by n plus 2 whole square. From the numerator, from the term n plus 1, let us take n common. What do we get now? Limit n tends to infinity, as limit follows here, n square into n cube times 1 plus 1 upon n. Here from n plus 2, let us take n, but square is there, you get n square into 1 plus 2 upon n cube by n square, n only. So limit n tends to infinity, we get n times 1 plus 1 upon n by 1 plus 2 upon n. As n approaches to infinity, 1 by n, 2 by n tends to 0. This is 1 plus 0 by 1 plus 0, but n is there. Here infinity into 1 plus 0 by 1 plus 0. Infinity into 1 is infinity, that is positive infinity. So that means greater than 1. When it is greater than 1, we can state that hence sigma un is convergent. I hope you might have followed this question, right? So whenever the given series is consisting of factorial terms, we need to apply D'Alembert's ratio test. But besides, we have geometric test and also as well as P test, comparison test, but we need to apply D'Alembert's ratio test. Right, let us move to the next question now. So let me repeat this question once again for better understanding. Here, ninth question, 1 square into 2 square by 1 factorial plus 2 square into 3 square by 2 factorial plus 3 square into 4 square by 3 factorial plus 4 square into 5 square by 4 factorial plus dash. So without finding the nth terms of the respective arithmetic progressions, directly we are able to write the nth term also here. Because 1, 2, 3, 4, 1 square, 2 square, 3 square, 4 square means obviously n square. Difference between 1 comma 2 is 1. So n plus 1 whole square followed by numerator is the product of n square into n plus 1 whole square. Denominator 1 factorial, 2 factorial, 3 factorial, 4 factorial. By observation, we can write its nth term is n factorial. Am I right? But moreover, here 1 comma 2 comma 3 comma 4 are in AP. So nth term is a plus n minus 1 into d, 1 plus n minus 1 into 1, 1 plus n minus 1, 1 gets cancelled, we have n. So now 2, 3, 4, 5 or in AP that is 2 plus n minus 1 into 1. 2 minus 1 is 1 plus 1, so n plus 1. Now 1 factorial, 2 factorial, 3 factorial, 4 factorial, obviously nth term is n factorial. Therefore, un is given by n square into n plus 1 whole square by n factorial. Now we need to find out un plus 1. In the place of n, write down here n plus 1. So n plus 1 whole square into n plus 1 whole square by n plus 1 factorial. N plus 1 is n plus 2. So un plus 1 becomes n plus 1 whole square into n plus 2 whole square by n plus 1 factorial. Am I right? So now next we need to go for, we need to simplify un by un plus 1. Un is n square into n plus 1 whole square by n factorial divided by un plus 1 is n plus 1 whole square by n plus 2 whole square by n plus 1 factorial. Am I right? Now numerator into reciprocal of the denominator, reciprocal of this reciprocal of this one. So n square into n plus 1 whole square by n factorial into n plus 1 factorial by n plus 1 whole square into n plus 2 whole square. So this n square into n plus 1 whole square by n factorial, n plus 1 factorial can be written as n plus 1 into n factorial, n plus 1 whole square got cancelled, n factorial got cancelled. We have n square into n plus 1 by n plus 2 whole square. By D'Alembert's ratio test, limit n tends to infinity un by un plus 1. So limit n tends to infinity, now n square into n plus 1 by n plus 2 whole square. From n plus 1 take n common, n into n square is n cube, 1 plus 1 by n. If you take n common out from n plus 1, divided by similar manner from n plus 2 take n common, that is n into 1 plus 2 by n, but whole square is there, here whole square I don't forget now. Actually n square into 1 plus 2 by n whole square, here also 1 plus 1 by 2n whole square you will be getting. Limit n tends to infinity, n cube by n square is n into 1 plus 1 by n, 1 plus 2 by n whole square. So this we need to write now, this one, wait for a while. This is 1 plus 0 by 1 plus 0 whole square. 1 by 1 square is 1 only, 1 by 1 1, 1 into infinity infinity. Infinity is actually greater than 1. So sigma un is convergent. Convergent. So this is the problem. So in the next session we will discuss some more interesting problems on this D'Alembert's ratio test only, because it is very important the examination point of view. Some more problems we shall discuss in the next session. Thank you. Bye bye.